So we're still working in Chapter 7, and I thought we'd take a look at problems 73 and 75 together because they're really linked. Okay, problem 73 asks for the number of orbitals in a variety of different places. In the 5p orbitals, in 3dz squared, 4d, n equals 5, and n equals 4. Okay, and we can use a basic chart to show this. And when we look, for example, at 5p, okay, so first of all, this only goes through 4, but as we can see, there things are repeated. So we have a 2p, a 3p, a 4p, and they're the same for each one. So a 5p would be exactly the same. Okay, so there are 3 4p orbitals, there are 3 3p orbitals, 3 2p orbitals, and so there are also 3 5p orbitals. Okay. The next one is 3dz squared. Okay. So there are 5d orbitals, as we can see from the 3d and the 3d and the 4d section. Okay. But only one is going to be 3dz squared. So there's only one 3dz squared orbital out of the 5 3d orbitals. Next they say 4d. Okay, so we have that located right here where it says 4d, and then we can see them: -2, -1, 0, 1, and 2, and there are 5 4d orbitals. All right. Next we have n is equal to 5 and n is equal to 4. Let's go ahead and answer n is equal to 4 first. Again, if we look up at our chart, when n is 4, we have L values of 0, 1, 2, and 3, 4s, 4p, 4d, and 4f, and then the m sub L values that coordinate with those. And for each one of those, so we have 1 4s, 3 4p orbitals, 5 4d orbitals, and 7 4f orbitals. So for n is equal to 4, we add these all up, and we get 16 orbitals. Okay. So if we look at these, we can see that with each one, when n is 1, we have 1 orbital. Okay. And then we have s and p's in 2, and sp and d in 3, and sp, d, and f in 4, which means that in 5 we would have 1, 3, 5, 7, and our g orbitals. Okay, so when n is equal to 5, we have the 16 orbitals from s, p, d, and f, and then we also have our g orbitals. Sorry about moving the paper. And there are going to be 9 of those because we're just following through 1, 3, 5, 7, and the next one would be 9. Okay, so that means that there are 25 orbitals altogether, and then n is equal to 5 range. Okay. Now if we just go over here to problem number 75, now they're asking for number of electrons. So basically each orbital can have 2 electrons in it. That's that spin quantum number, plus 1/2 minus 1/2. So I've actually got these going up backwards because I want to deal with them in the as they sort of correspond to the problem in number 73. Okay, so we said here that in the n is equal to 4 orbital energy level, we have 16 orbitals. And since each orbital can take 2 electrons, then that means that we would have 32 electrons in, whoops, sorry about that, that's all over the place, and the n is equal to 4 orbital. Okay? Alright, now in n is equal to 5, m sub L equal to plus 1. Okay? So this describes 1 orbital here. But the trick is that there's a plus 1 orbital when L is equal to 1 and when L is equal to 2, and when L is equal to 3, and when L is equal to 4. So there's n equal to 5, L equal to 1, m sub L 1. There also exists n equal to 5, L2, m sub L2. N equal to 5, L3, m sub L1. Okay, this L value is located in each one of these. Okay, so as an example, we can come back up here and say, okay, well, when L is 1, here we have our m sub L value at 1. When L is 2, here we have our m sub L value equal to 1. When L is 3, we have an m sub L value equal to 1. So if we added in a 4 here also, we would also have an m sub L value equal to 1. Okay, so back to this. This means that there are 4 orbitals in this n equal to 5, m sub L equal to 1, which means that there are going to be 8 electrons. Okay, now we go up here, so we're still in the n is equal to 5 orbital here, but now we have m sub s equal to plus 1/2. Okay, so the reason that these are linked is because each orbital here contains 2 electrons. In each of these orbitals, one electron is plus 1/2 and the other one is minus 1/2, which means that there are 25 electrons in the n equal to 5 energy level that have a spin number of plus 1/2. Because each one of these 25 orbitals has one electron that could go into it that's plus 1/2 and one electron that could go into it that's minus 1/2. So it would have 50 electrons altogether. Alright, now let's go up here. Now we have n is equal to 3, L is equal to 2. Okay, how many electrons are in there? Okay, so this one is a little bit more specific. If we go back up to our table and we see that n is equal to 3 and let me see again. Oh, sorry. And L is equal to 2, then we have 1, 2, 3, 4, 5 orbitals in n equal to 3, L equal to 2. Okay, there are 5 orbitals here for the 5 m sub L values that go with L equal to 2, which means that 10 electrons could be in those 5 orbitals. Okay, and now we're up to E, where it says n is equal to 2 and L is equal to 1. Okay, so we can come back up here and we see, okay, well, n is equal to 2 right here, okay, and L is equal to 1 here, and it lists over here that we have 3 orbitals here. Okay, so there are 3 orbitals in this area. Okay, and that means that we could possibly have 6 electrons in those 3 orbitals.